Hi, welcome. Tonight we're picking off right where we left off last time. Just working more on these value nodes that we introduced last time. So again, I was looking at Blender, how it does things, and I was looking at this kind of workflow where we generate a checker texture. If we just pass that in right in here, you can see just, red, blue mixed with a checker texture with a scale value. We can actually do it this way in Blender. It's pretty nice. And then if we pass it through this RGB to black and white node, the color is converted to a value, what I call a value now, which is just a float. And then that's passed in to another color input here. And I think this here, I haven't looked at the code, but I think this implies a conversion. So what I think they're doing internally is something like, something like this. So they're taking this, plugging this into all these, so we just convert the RGB with all the same values, just stick that in all the channels and then do something like that. I think that's what they're doing internally, and I think that's what we'll do as well. Now the level at which we would do this kind of, infer this, okay, you're plugging a value node into color. I think that's in the interface, like whatever generates that node graph then gets turned into JSON in the case of C-Ray. I think that's the place where we want to do that, not like internally in the nodes to like check the type that's passed in and stuff like that. I think that's more like, you can do this kind of stuff in the kind of user interface layer. So what we'll have to invent is this RGB to black and white node, which, well, we already have that. See, that's the one we did a while ago, the Grayscale node, which takes a color node, and then right now it returns a color node. We haven't refactored this yet to use value nodes, so we'll do that first, and then we'll make another node that converts a value node back to RGB, just undoing, not undoing, but just turning a single value to a color output. So that's where we'll start, because we need to actually refactor some of this stuff. So this should return a value node. And then also like mix should take a value node for the input. And then if you want to pass in an RGB texture as the value input, you have to convert it. So right now in this GUI, we have the RGB to black and white in Blender, but we don't have the other way, see? So the other way is it's kind of implied. That's what I'm trying to say. So let's try and do that. Obviously, at the level we're working in, it's not going to be implied. It's just we're gonna have to put the call in and put it in the JSON as well. But I don't think that's too bad. You just need to convert that. Where should we start? Let's maybe start by making Grayscale Converter a value node instead of a color node. Right. So we'll just start with this and see where we get. Value node. I think we just want to add value node here as well, because we need both for, yeah. So it's value node, takes a color node as an input, and then this will be a value node. It has the original color node just as it did before, but the sample eval grayscale returns a float. Right? And also we can rename this to eval, because again, static while we're in here. And then, let's see. Yeah, so grayscale is what it does now. So wait, this turns it into, okay, so we would turn it into grayscale, and then I guess we would return just dot red. Wait, dot red. I don't know if that's a good idea. Yeah, so let's see. Grayscale. No. We passed that into grayscale. This returns a grayscale color. And since it's inline, can't we do this? Right, no, that's what I was trying to do. Anyway. Then construct value node. so value node, and then we don't care about the hit record. Actually, do we care about the hit record? No, we don't. We do though, don't we? That still won't work. So usually we don't want to. I guess value nodes should have the record as well, right? Shouldn't they? Right, like, let's see. So vector node doesn't have it for now, but yeah, I guess we do want that record in there, huh? Color node takes a record. BSDF takes a record. Yeah, let's just stick that in there. I don't see, because that's basically how we do the mapping, right? Because we need to know, we need to pass that to the eval function of the color node, right? Anyway, so let's just put this in here. Should we put it in here? How do we do these? I'm just looking at the other ones, for example. Color node H. Record, what about like diffuse constant color? Take the thing last. Okay. Eval. Yeah. I think, Factors taken last. These don't really care about it, don't they? This one takes it like this. Okay, yeah, whatever. We'll just stick this in value node right there. Eval function. And we'll do the same for the vector node while we're at it, because it's a very similar change. Vector node C, constant vector. It'll have this as well. Same for value node. And then we don't care about the record in these. Right? Don't care. Don't care. And this one wants record right there. No, wait. This way. Oops. Build that. Okay, that builds. Will still work. Just do a little test render here to verify that it works. Try to set up. It's really hot. Okay. Cool. We don't need, like, let me close my other terminal. I've been having this weird thing where if I have a terminal on my second screen and I tab back to terminal.app, it always goes to the one on the second screen instead of the one that's obviously the one I'm using, which doesn't make any sense. It's only done that recently though, so I'm sure it's like broken. So for this command, we only need like 10 samples. That's fine. Okay. That works. What about other nodes? Color node also takes the record. Yeah, I think this is more consistent. They all just, the sample function takes the record so I can map stuff. That makes sense to me. That's a commit. Patch vector node. Yes. Yeah. 8. Yeah. I'm sure there's a faster way to do this. Yeah. Nope. I guess I'm not using the Grayscale converter anywhere, right? Yeah, I'm just defining it at the moment. I'm not using it anywhere, so that's fine to put this one. Do we want to put this one in? We don't, right? So Grayscale. No. grayscale.c. No. But yeah, let's just stick that in there as well. Yeah. 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 Okay. So it's passing in the record for this one needlessly, but it's consistent. Right. Color for Calvin. Yeah. Okay. Okay. I think that's good. Nah. Okay. Hit record to eval functions for and vec. Trying to make it fit at least. More consistent is also required. I should have mentioned that, but whatever. Okay, so now we have that. Then we can go about doing this value node grayscale thing. So this is a value node, which right now, since it converts the original color to grayscale, that means after the grayscale is done, all the channels will be the same. So that's why I'm just picking the first. Does it actually set all the channels to the same? It keeps the alpha unchanged, so that's not changed. But yeah, these are all same. Okay, that makes sense. Now let's use it for let's do mix first. Value node that, and then that's gonna be value node. I take a value node and sample. It's breaking. Okay, so now we don't need to do the grayscale in here. Instead, we just get rid of this. It's just moved to the other place. And in here, instead of doing this one factor, it's going to be a new constant value of 0.5. New constant value world of 0.5f. Because that gray color thing was just a color of all 0.5. That was a hack. Right? That should work. Maybe I should have done this in the last video. This is actually fairly simple. So now, here we got the issue. This was at the end of the last video. I was like, I got to this far, and then was like, oh, I'm not going to do that in this video. We need to convert the constant texture here to grayscale. So let's invent that node. And this, again, will be the implicit conversion in the final, what's presented to the user, but we're going to do it, explicitly inside. I think that makes more sense, I think. So let's just add a new one. We'll just copy the grayscale one. What do we call it though? Value to color. That's awful. Because Blender has RGB to black and white, and then there's the invisible one. It's gonna have to have some horrible name, right? If you can come up with a better one than I can, do let me know. We're gonna call this value to color. We're just gonna do that. Grayscale. I will call it combine, since that's kind of what it does. We can do 2 different types in here. One that takes a single value and one that takes RGB. Let's do that. Combine node. I like that. Again, do my little finagling here. We'll just copy this directly. I'm not gonna bother with trying to write it from scratch. Already got all the... Whoa. Whoa, what just happened? Whoa. That's gnarly. I don't know how that happened. I just grabbed it in the middle. That's weird. Anyway. That's hilarious. Combine. Cool. Yeah, we have duplicate symbols. That's fine. So combine.h. This will take a... Wait. This will take a value node and return a color node. Right. It's a bit... mapping these nodes, like these are super obvious, but then mapping them to code. Value node. Yeah. Cool. New value to color. Let's call it that. New value to color. And then value. Then we'll have like something like combine RGB node. So this will take a value node. Value node, and then this will take a trying to practice my keyboarding here. It's about time. So R G B B. Oh, B B. There we go. Whoa. B star. Cool. So we'll do that next, but we'll do the combined value first. And then this, wait a second. So this will be a color node. Same for this boy. And then these will be value nodes. I'm messing this up. Right? And then these could be split into separate files. We'll do it in the same one for now. Maybe we'll stick these in different files actually. Why not? So that would be combine value and then combine RGB. I'm kind of not digging this whole idea. All these, like almost all these, are lowercase, and then the tests are like snake case, combine RGB. But then there's like some like light ray here. That's just camel case. I don't know. It's weird. Like I made it in 2017. That's when I created the name. I guess I was feeling camel case that day. I just didn't notice it until like recently. Like almost all of these are just lowercase, the file names. Do we have anything else? Terminal, loaders. They're all pretty consistent, but that one file there. Yeah, these are libraries. These are not named by me, so that's like whatever. But yeah, it's very consistent, except for good old light ray. That's funny. Let's get back to this. So let's do this. Combine. So this would instead take combine RGB. This would still be a color node. Instead here, it's gonna take 3 nodes here. Oops, not G. B. Then we'll do this like that. Combine RGB, and then this will be like that. And I think I have it in the clipboard. No, I don't. This one. deal with this later. I'll do the combine one first. Get rid of this. Okay. I think this makes sense. So compare this. So combine value. Whoa. Cool. It's kind of cool how I can mostly just, if they have the same structure, I can just change the type and it'll work. Which does really make me think I can do something about these, so you have to write those. Okay, so we take a value node and return a color node. The eval will be like this, and then this will return struct color first of all, and struct color, bam, and it'll just return node, no, this value, original eval, this original record, right, and then we will put that in a temporary. I have to call it multiple times, float. Creative naming. And we'll do like what do we do for the alpha? Just that? I don't know. Let me think. So we get a value node. There's nothing we can really do for the alpha. I'm gonna just guess that we just set it to 1.0 and I'll regret that later. What do we do with the alpha here? Okay, cool. Oops. Then grayscale struct of combine value. Will that work? Eval. Color node. All right. Yeah. So we have a struct value node. Oh. Combine value. Value node. There we go. There we go. Okay, cool. That took me way too long to figure out. Okay, that makes sense. Let's deal with this. Value node. This we are gonna have to deal with. This one, did we deal with that here? Yeah, we did. Okay, cool. Cool, and then this, 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 and this. Let's go fix up the types first, so it gives us good warnings. Yeah, so okay. So here we're gonna do dot r. Cool. Eval takes this is gonna take combine RGB is, yeah, it's a color node. Returns a color node. But how does this not warn us? Let me fix these and I bet it'll warn us about that. So this A is equal to other A. I'm really tempted to oh no, right, R. Tempted to name it to this and that so they're the same length, but I'll do that later. This and other I don't know. And G, B. Cool. If this hashing and comparing confuses you, that's for the hash constant. I explained that in the last video, how that works. We're gonna have to do this, so R, same sort of deal. Cool. For the eval here, it'll take the combine RGB node and it will return a struct color. We'll complain about that now. Cool. For this one, we'll do well, for this we can't really get around it. I'm not gonna do them. Actually, we'll just do this R eval this R record blue B eval this B record. This is the type of code that's really easy to mistype. Oh no, yeah, like there. Let me do these in the right order at least. Cool. We'll do again for the alpha there. What do we do with the alpha here? Cool. This is the same one we had before, so initializing value node with value node. So this is value node float. No, but then combine. What do I do last time? So the eval returns a color, takes a node and a record. Same as there. This is a value node. Gears are turning. Try me the full thing. So float. We're trying to put it with, yeah, struct color. But I thought we did this the right way, value node. No, this should return a color, right? Right. Struct color, color node, record, value node. Wait, what am I trying to do here? I got confused. So we're trying to do something like this. So like, combine RGB, takes 3 values and returns a color. So this needs to return a color node. And 3 value nodes are taken here. We can't have the how is it different from this? Here we take a single value. Why am I confused? Combine value, combine RGB, value node, and value node. then. Why is this so hard? Hashing is all good. This makes sense. valueNode. valueNode has that, right? What does valueNode take? So this one takes a valueNode and a record. A valueNode and a record. And returns a float. What does this return? This returns a color. How does this work? How is this allowed to return a color from a valueNode? How did this not warn us? What's the linker error? New value to color and combine RGB and color. Value to color. Oh. New combine RGB. Maybe it'll give us better warnings if we fix these. How is this allowed? I'm really confused right now. valueNode and original. Takes a valueNode. It is a valueNode. How is this allowed to return a color node? How can we even cast that? We can't cast that to a color node. Why is this not warning us? This ain't right. Why is it not warning us here either? So inside hashcons, we combine it, cast it to T. Well, we return a void pointer from the hash table. There's an implicit cast inside there. We can't cast valueNode to a color node. That just won't fly. These need to both be color nodes. Right. But color nodes can't take more than these. We set those in there. Now we take the color node. I guess it's just of type color node then. Yeah, because we return a color node. That's fair. Okay. Yeah, I guess that makes sense. So color node, and then this takes just the color node, right? Yeah, I guess that makes sense. Yeah. Okay. That one. Yeah. Okay. Let's try these. Again, we're gonna go into assign BSDF and override this stuff. And mat BSDF is new diffuse world, and we will make a new combine. Oh, we need to expose those. So combine and combine RGB. Where is that? Yeah. Okay, got really confused for a bit. I think we're good. Yeah, I need combine RGB world. New constant. This is a bit of a roundabout way of doing this, but that's intentional. World, and we'll do red max, and then new constant value world 0.0 for this, and new constant value world. Trying to do like a pink material. Right, so this is a roundabout way of saying that BSDF is new diffuse world, new constant color. Wait. What was the constant texture? Texture, yeah, constant texture. It should be called constant color. I forgot to rename those. So here we just directly give it a color. So struct color pointing of 0.0. Right, so these are functionally identical, like they should be. We'll see if this bottom one works. Hopefully I did everything right. Oh, I didn't. Okay. I think it'll crash. Oh, look at that. It actually works. But we gotta fix these errors. Okay. This is unrelated, but scene loader. Scene loader. See, what was that? 923. 923. Oh, right. So here we changed the API for new mix to take a value node. So we're gonna have to make a thing that converts the color node to a thing, which we already did. So new grayscale color. Yeah, this one, world, and then put this in here. Oops, don't do that. Right. So that's the new API. So we need to make a new grayscale converter that turns it into a value node. Okay, that makes sense. I wasn't using that for this scene, I don't think. Actually, yeah, I was, but I don't know how it worked. Nice. Okay, cool. So that works. Let's make a commit out of that. Why is my notifications enabled? I thought I disabled those. That's weird. I disabled those. Anyway. Git add on. Patch. Scene loader. You know, for me, it's quicker to use source tree. Let's just do it here. Yeah. Yep. Yeah. So the like combine that combines a turning these turn valueNodes into color detail. Right, cool. Okay, why is there? Yeah, this is, we're gonna ignore that. So what did we set out to do? So we set out to use the checker texture. Let's do this scene now and see if that checks out. So get rid of this. Mat BSDF is new mix, and this will be world. We'll do the new diffuse of red world. New texture. We'll rename those functions in this video, but we'll do that in just a bit. Red color. New constant texture world. Blue color. And then this factor is now a value node, which here. So wait. Well, we're generating the checker texture directly here. The way it's done in C-Ray is not like this. It's done a bit differently. So we have a mix node. mix shader that takes. Yeah, let's rebuild this so it's works the same as in C-Ray. So checker texture actually could return a color, and would we do that? We could do that actually. Let's do it that way first. That PSTF is new checkerboard texture, color checkerboard texture. Then we have do colorNodes, and I guess checkerboard uses diffuse internally, doesn't it? It's kind of weird how it takes doesn't take two shaders, it takes two colors. That is kind of weird. Because I would expect it to take two shaders in here, but we can do that. It's just done in a roundabout way. So the way I would instinctively do this, let's do even another one, is mat PSTF is new mix. Then we'd mix them. New diffuse world, new constant texture, world red color, new diffuse world, new constant texture, world blue color. Then we'd mix these with a new checkerboard. And this actually needs to return a value node, which we will do right now. We'll add a little to do here. Change to value node, because this now returns grayscale data. That wouldn't just return value data, but we can get around that now by using a new grayscale converter, world, and new checkerboard texture, world 500 or something. So this is how I do it. But there's multiple ways of doing this. So let's make that in Blender as well while we're at it. So we get the checker texture. Yeah, that works. The scale is a bit weird because it's interpreted differently in different places, but that works. So there's one way to do that. Another way would be to checker texture. Have these to be like all black and all white. And then use the, well, I guess we could use the factor output. This is done like using like a grayscale conversion. And then use a mix node here. Plug the factor in here. And then do the diffuses manually. Get these colors from in here. It's getting a bit involved, I guess, but there. This is the way I was doing these before. Now you can choose the material you want. For the actually, yeah, checkerboard texture is just the texture, right? It is color data. I was confused before, but yeah, this works as well. This is now what we're doing is this one. So we're making two diffuses, diffuse and diffuse with red and blue, and then modulating between them using this checkerboard texture. But right now, we need this grayscale converter here. But let's just make checkerboard texture return values instead. Let's see. So we have the checker here. And one of them is a color one, which returns color data. And then the other one, but then we only have this one. I guess it makes sense for now, because right now we are wanting to do this, right? Yeah, so we were effectively, what we set out to do today is to make this one, and that's now right here, new grayscale converter. That's what we're doing. So this is kind of annoying here, but that will be implicit in the UI eventually, but it's explicit in here. So yeah, I guess we already done, right? We don't need to do any more. This is just one way to do it, but we're actually doing it this way. which is much better. I was doing it this way before. Yeah. So let's get rid of that and that and do it this way. That's much simpler, right? We just get the colors and plop those right into diffuse. Wait. Yeah. Well, yeah. We could even do like so wait, hold on. We're not doing quite the same here. We'll do the one that Blender has now. So new color, checkerboard texture. And this will go to a diffuse. So new diffuse world, new color, checkerboard texture, world, and then new constant texture, world, red color, new constant texture, world, blue color. Okay, so this is what we're doing now. And then the size is just whatever, 5 there. So now it's in color. As you can see already, like for such a simple example, there's many ways to do this. I think it just goes to show how flexible and kind of how many opportunities this new system enables us, because this was all impossible like just 2 weeks ago. I wouldn't have even like dreamed of doing stuff like this a week ago. But now it's all like clicking into place, and that feels great. But now for this one, we can do what we set out to do today, this bit right here. We can just add it here, new grayscale converter, world, and then put another paren here, I think. No, wait. Grayscale converter. After this one. Yeah, that should work. What does that? No. That takes a color node. New color. Yeah, that's supposed to take a color node. New grayscale converter. What am I trying to pass in? Oh, W. There we go. And change the value node to color node. Well, now we're converting it to grayscale, then we need to convert it back to color. Right, so this turns it into grayscale, and now we do the implicit conversion, which I again forgot because it's not shown here. So yeah, this is the implicit part we gotta add. So combine, what did we call it? What do we call it? I forgot already. New value to color. We should call this new combine. Or, I instinctively went for new color and combine. So I'm gonna do new combine. And then new combine RGB is the other one. So new combine world. And then this takes a value node. And then this one has a parentheses here. Add one more paren. That should work. Maybe. We'll see. It's going to be a short one today. I think that's it for tonight. Let's figure out if this actually works. Color node to value node. How come? It works. Kinda. It doesn't quite work. Let's fix that. What am I doing wrong? BSDF node.c. Oh, we gotta fix this, right? Okay, so mix takes this one. This is color data, which we need to new grayscale converter world. Right, that. Cool. And then this could actually be simpler. We could just do, instead of a new grayscale and all that stuff, we could do Was it before 500, right? Yeah, it's much simpler. Cool. Why did that not work? What went wrong? It's not mapping something right? Or am I just setting the scale wrong? What happened here? It's getting mighty confusing doing these. Also, we need to really do the parsing, but I don't know if I want to do it here. We can diffuse where we combine, which turns it into a color. No. Why did this take me here? New combine. There we go. Yeah, color node. Cool. Takes the value node from here. And it takes a grayscale, color checkerboard, red color, and blue color. Although, I guess, okay, let's do like 200. It would not show up as, like, distinct. It's not black and white, it's gray and darker gray. Maybe it just doesn't show well? Pretty sure that's uniform gray. I'm pretty sure. Are we sure that doesn't work? Why does it not work? That should work. Because now we're doing what Blender's doing here. Make that RGB color checkerboard texture. Takes this one. Pretty sure that's broken. Let's fix that. I bet we can fix that. I don't know why it's not mapping right. So let me break this down. It's a diffuse with a combine with a grayscale converter. So it turns it into grayscale and then combines it back with the implicit there. Color checkerboard texture. Let's just make a new one here. Make sure that the first one works. So take this color checkerboard texture here, like this one. Plonk that in here. Make sure that works first of all. Oops. That works, cool. I'm just gonna tweak the scale back to like 200 for both of these. And why ain't no worky? We'll find that out. It's probably something dumb. So this works. But somewhere along the way, it turns this, it doesn't map it right. So let's first of all, wait, that's just a diffuse color. Yeah. So the diffuse color, the conversion, and a color checker. So we just bypass this like this, and it works. But this case doesn't work, and we're trying to find that out. Why is it like that? This works, and this doesn't. It should look something like this, roughly. Dark gray and light gray, right? It's not an absolute black and white, right? It's doing the grayscale conversion in somewhere. Okay, let's figure out where it goes wrong. How would we test that? Like piece by piece. So if we just turn that into grayscale, well, at least both have to work, right? So let's just look in here. Combine value. Oh, wait, hold on. Yeah, it gets the original eval. Yeah, combine looks good. What about grayscale converter? Takes a color node and turns it into grayscale. Again, turns into grayscale and then gets the red. That makes sense to me as well. Okay, so we get the color, turn it into grayscale. Here, take the red channel, plop it back into here. So now the red channel's in here. This gets the red channel. And we ignore alpha here. That's fine because we're doing the alpha mixing in the nodes now. We don't really care about it here. Or maybe we might at some point care about it. Right now we don't. So whatever the value we get in here, we should get back out in here combine. So let's do that. Let's put these, oops. See what happens. So first of all, we hit the eval for grayscale. So now we're turning it in, and the return value is float 1. Okay. And then we should right away hit the eval for grayscale again. Okay. And then combine. Oh, well, let's set that to one thread because we don't want to hop around different threads. Let's not do that. So we hit the grayscale first, and we return float 1. And then we should hit combine. We don't. Well, we have two different colors. So for this one, we have float 1 again, which is suspicious. Now we should hit the grayscale. No, combine. Return value 1. Grayscale again. Okay. Grayscale again. Again. Why is the other one not getting hit? Well, we just remove this. Okay, now we get this. Now we get 0.333, which is 1 divided by 3. So we're always getting float 1s in that grayscale converter. Why is that? Let's first of all figure out what the original color is. Just hop out and then into grayscale. The color ends up being all white. Why is that? No wonder it's getting so obviously it's gonna return 0.33. Well, wait. What happened there? I'm confused again. Alright, so first of all, we get the color, evaluate the color. Eval checkerboard makes sense. We get the color back. All 1s. Okay, fair. We pass that into grayscale. All 1s again. So it's going to be, 3 divided by 3. Yeah, okay. White, yeah. So this returns 1. And then we take the red channel. All these channels are the same. So we take the red channel. Okay, so why do we get all whites when we obviously don't have... We don't have white here. We have red color and blue color. Where does it get the white from? It gets it from here, but why? This original evaluates the checkerboard. Color A. Okay, scale is 2. Oh, you know what? This scene has a bunch of other things that are like not at all. Okay. This is a bad scene, I just realized. Like, it can be anything in the scene, which, yeah. Yeah. The first thing that it would hit might be this one, which is black and white. Okay. Why are these gray then? Let's just look at what we get in Grayscale then. Or like the combine thing. We get 0.33. Cool. Well, this is gonna take forever, right? Just stop it for a bit. Let it go for it to do its thing. Come back. We should change this scene. Let's geez, how would we? Let me do something, but let's make a better test scene so we can figure this out quicker. So copy input UE sphere input combine node.json. Combine node.json has a single sphere which does not have it's got this one. We'll bypass that. Okay. What do you combine node? Let's see what we get here. Right, and then, yeah, okay, that's a good test scene. Not the other one. Cool. What do we get? 0.333, 0.3343, okay. Sure. Why do we get that? Debugging. So color checkerboard returns our stuff. Grayscale converter will get that. Let's steppy in and steppy out. So yeah, it's red. Okay. And then we turn that into grayscale. Right? Which turns it into 0.3333. You know what? Actually, yeah, this makes sense now. Okay, so why is this? Their brightnesses or something are different. But how do we? Was there a way to RGB? Mix RGB? No. Separate RGB? No. Well, that's a cool node, by the way. RGB. Let's do combine RGB. Let's do it this way. So this one's red all the way. And combine RGB. And this is blue all the way. These should be identical when turned to grayscale, right? Why does Blender show them like that? Let's see what Blender does here. Why is there a brightness difference? These should be identical. Okay, I guess Blender is doing the grayscale conversion differently. I think it's doing like a luminosity thing because I think C-Ray is working correctly. It's the grayscale conversion function here that is like super simple. Like this is the most naive way to do this. Is just add them together, divide by 3, and stick it in there. We need a better grayscale function, don't we? Obviously, Blender is doing something different. Let's try and find a better formula for that. I'm not gonna invent one because I'm not genius. So, B2 grayscale formula. Maybe Blender can tell us that. RGB to BW. Blender RGB to BW. Let's see what their documentation says. Maybe there's clues. By the luminance. Okay, we might not be able to do this yet because C-Ray works purely in. What I'm trying to say is that C-Ray is working correctly right now. It's just working differently from Blender. C-Ray works completely in the RGB space. It doesn't have any other color spaces right now. And what I'm betting that Blender does is it converts it to like a different color space that has the luminance like separately, and then takes that luminance, which we can't do yet. I'm not gonna. Yeah, this is where we get to like color space stuff. So I'm gonna call it here. I'm gonna look into this color space stuff off camera and maybe do it. But C-Ray is working correctly. It just happens that in C-Ray, R1 and then B1 just happen to come out identical. So let's do assign SDF and just set this to like frame color, which is like an orange color. Now it'll at least be somewhat different. So we're just doing a stupid way of converting color to grayscale, but yeah, there you go. It's working, just not quite the way I expect at the moment. So I think that's it for this video. If you got this far, thank you very much for watching, and I'll hope to see you in the next one. Goodbye.